Assalamualaikum. My name is Nura Alwanis binti Aznan. Me and my group going to present about high performance liquid chromatography (HPLC). For the group members, we have Nur Sharafana binti Abdul Jaffar, Irene Batrisha binti Anis Sirman, Tengku Batrisha Musfirah binti Tengku Rozahan, and me, Nura Alwanis binti Aznan. Lastly, Muhammad Izzuddin bin Rahman. For the contents of our presentations, we have introductions, methodology, results, discussions, and conclusions. The objective of the experiments in these presentations is to determine the retention time of the standard solutions. Second, to identify the caffeine peak in a soft drink samples. Lastly, to determine the amounts of caffeines in a soft drink samples using the response factor method.
Assalamualaikum and hi, I am Musfirah and I'm going to introduce you to the Hplc, which stands for High Performance Liquid Chromatography. Hplc utilizes a liquid mobile phase to separate the components of a mixture. The analytes are first dissolved in a solvent, as it must be in form of liquid, and then forced through the column under high pressure. Hplc is very versatile because of its ability to easily separate a wide variety of chemical mixtures, which include non-volatile and thermally unstable compounds. For example, organic, inorganic, biological samples, synthetic or natural polymers, and thermal labile compound. The applications of HPLC applies to any compound with solubility in a liquid that can be used as a mobile phase. Analytical or preparative, where it needs highly purified compound in either small or large quantities. The applications include analysis of sugars, pesticides residue, organic acids, lipids, amino acids, toxins, and vitamin. HPLC also offers a lot of advantages, and some of them are greater sensitivity as it has various detectors, a reusable column so it can host many analyses. It is also very ideal for ionic species and large molecules. Last but not least, Hplc offers sample recovery as it has fraction collectors.
Hi and Assalamualaikum. My name is Nur Sharafana binti Abdul Jaffar and my student ID is 2021631078. And what I will present to you about my part, which is methodology of the HPLC experiment. Firstly, what is the principle of HPLC? The principle involved in HPLC testing is the separation of compounds in a mixture more efficiently and also quickly than that of traditional column chromatography. And the concept used is LDL, light dissolved light, and this is one of the principles for chromatography. And the image shown here are the HPLC system setup, and the division of compounds is due to their relative difference in travel through the column on the application of pressure exerted through the mobile phase or carrying liquid. HPLC also involve the injection of small volume of liquid, which is sampled into a tube packed with small particles, and each component moves down with a liquid called mobile phase through the column with high pressure. And then the division of this compound is due to their relative differences in travel through the column, and the compounds of the mixture travel at different rates due to their relative affinities with the solvent and stationary phase. And then the compound with a higher affinity towards the stationary phase of the column will move more slowly and vice versa. And then the above principle is similar to that of the column chromatography, but in HPLC the separation is more efficient due to greater surface area achieved due to a tiny particle size of stationary phase in comparison. But we use that in the column chromatography. Okay, for the next slide, for the block diagram of HPLC, the caffeine standard or Levita and Koch sample will be going through firstly the solvent reservoir. Mobile phase contents are contained in a glass reservoir, and then the mobile phase or solvent in HPLC is usually a mixture of polar or non-polar liquid components whose respective concentration vary depending on the composition of the sample. And then next, for the pump, it aspirates the mobile phase from the solvent reservoir and forces it through the system column and detector. Depending on several factors, including column dimension, the particle size of the stationary phase, the flow rate and composition of the mobile phase, operating pressures of up to 42,000 kilopascal can be generated. And then next, for the sample injector, the injector can be a single injection or even an automated injection system. 0.1 until 100 milliliter of volume with high reproducibility and under high pressure. And then for the columns are usually made of polished stainless steel and are between 50 and 300 mm long and have an internal diameter between 2 and 5 mm. They are commonly filled with a stationary face with a particle size of 3 to 10 micrometer. Columns with internal diameters of less than 2 mm are often called microbore columns. Ideally, the temperature of the mobile face and the column should be kept constant during an analysis. For the first step for column part sample will be introduced, then the sample go through the separating process into its individual components. The sample will go through together with the mobile face and stationary face. Mobile phase is a phase when the solution is being separated and have low viscosity and low compressibility. Meanwhile, for the stationary phase is a material being placed into a column. Usually it's contain like gel, silicas, aluminum and sand. And stationary phase function to allow mobile phase to go through it. And then for the detector, the Hplc detector located at the end of the column to detect the analytes as they elute from the chromatographic column. And commonly used detectors are UV spectroscopy, fluorescence, mass spectrometric and electrochemical detectors. And then lastly for data acquisition. The data acquisition is data collected on electronic device that will be produced from the signal of detector, and then it will integrate detector response to each component and change it into chromatograph. And then the example for data acquisition is like computer, laptop and printer.
Assalamualaikum and hello, I am Irene Patricia. I will be talking about the results and a bit of the discussion. On to the results. This slide shows Figure 1, graph for determination of caffeine in standard caffeine. Figure 2, graph for determination of caffeine in Coke. And lastly, Figure 3, graph for determination of caffeine in Levita. This is the tabulated results. The high-performance liquid chromatography HPLC analysis yielded valuable insights into the retention time and peak areas of caffeine in all samples, successfully fulfilling the experiment's objectives. The caffeine standard exhibited a retention time of 2.482 minutes and a peak area of 6,249.48779. These results will be used as reference for identifying caffeine in other samples. The Coke sample displayed a retention time of 2.481 minutes, almost identical to the standard. This confirms the presence of caffeine in the soft drink. Its peak area was 7,001.12305, indicating a higher concentration of caffeine compared to the standard. For Levita, it showed a retention time of 2.49 minutes, also near identical to the caffeine standard, with a noticeably higher peak area of 11,151.10000, suggesting that Levita contains significantly more caffeine than both the standard caffeine and Coke sample. For the discussion, based on the results before and the caffeine standard results, Levita has the highest caffeine concentration. Using the response factor method, the relative caffeine content in the samples was quantified by comparing their peak areas to that of the standard. This method indicated that Levita has the highest caffeine content, followed by Coke, basing on the caffeine standard solution. These findings not only confirm the presence of caffeine in the soft drink samples, but also provide a quantitative measure of their caffeine concentrations, fulfilling the objectives of the experiment. These results prove that the HPLC method effectively and accurately separates caffeine from other components in the soft drinks, as the retention time of caffeine for all samples were almost identical. The small variation in retention time might be due to potential minor differences in the column packing or mobile phase composition of the HPLC.
Hi and Assalamualaikum, my name is Muhammad Izzuddin Rahman. So I will be going to talk about the past year question for discussion. So we have A, so it asks to explain the term gradient illusion mode in HPLC. So illusion mode in HPLC refers to how the mobile phase moves through the chromatography column. So the first illusion is isocratic illusion, which uses a constant mobile phase composition throughout the run. And second, we have gradient illusion, which involves changing the mobile phase composition during the run to improve separation of sample components, especially useful for complex mixtures. And then we have B. It asks to differentiate between gel filtration and gel permeation chromatography. So gel filtration is a size exclusion chromatography with hydrophilic packing are used with aqueous mobile phase, and it is also a separation of polar species, while gel permeation is a size chromatography with hydrophobic packing and are used with non-polar organic phase, and it is a separation of non-polar species. And then we have C. So it says the following organic solvents were used in reverse phase Hplc analysis. Propose the elution order of the listed solvents and give a reason of your answer. So the listed solvents are propanol, propane propanoic acid, and ethyl propanoate. So the correct order is propanol, ethyl propanoate, and propanoic acid. Why I will say propanol, then ethyl propanoate, and then propanoic acid, it is because propanol is a polar solvent due to the hydroxyl group attached to the propane chain. It typically elutes early in reverse phase Hplc due to its polarity. Ethyl propanoate is less polar than propanol but more polar than propanoic acid. It contains an ester group which influences its interaction with the stationary phase. It generally elutes after propanol. And last, propanoic acid is the least polar among the listed solvents because it contains carboxylic acid group. It interacts less strongly with the stationary phase and typically elutes last in reverse phase Hplc. Therefore, the correct elution order for the listed solvents in reverse phase Hplc is propanol, ethyl propanoate, and propanoic acid.
We proceed with the conclusions. In conclusion, these experiments have determined the retention time of standard solutions of caffeine, which is 2.482 minutes. Then, the caffeine peak area in the soft drink samples 1, 2, and 3 have been identified, which sample 1 has 57.3551%, sample 2 has 55.3200%, and sample 3 has 100.0000% of peak area. Next, the amounts of caffeine in soft drink samples have determined using the response factor method. The concentrations of caffeine in sample 1 is 28.988 ppm, sample 2 is 48.82 ppm, and sample 3 is 119.17 ppm. Next are the applications of Hplc in the food experiment analysis. Food analysis methods are built around high-performance liquid chromatography, Hplc, which has proven to be an optimal technology for detecting and quantifying the vast majority of food analytes. This method employs a stepwise approach that first removes the sample matrix, then isolates the analytes of interest and individually resolves them on a chromatographic columns. The first stage of Hplc analysis is sample preparations, which involve the introduction of medium into which the target analytes can be preferentially partitioned, followed by separations of the analytes contained piece from the remains of the sample. The selection of the partitioning medium is determined by the nature of sample matrix and the properties of the analytes. The sample may be heated, have its pH adjusted, or otherwise treated to make the analytes more accessible to the partitioning medium. HP analytes can often be identified on the basis of their retention times and either their UV visible of mass spectra. Spectral information is especially useful identifying consulting peaks, which turn up fairly frequently in many food matrices. In such cases, diodes array detections across multiple wavelengths or scanning across the mass spectrometry range enables the convolutions of overlapping peaks. All from us. Thank you for listening.